Everybody, this is chapter 4, section 1. We're going to look at graphs. We're going to do some interpreting of graphs. So we're just going to kind of see what they say and then talk a little bit too about what makes up the graph. We're going to call those variables. And so when you deal with graphs, what we're looking at, usually there's two variables, okay? So in this first problem, we're looking at this graph. It's showing how much volume of air is in a balloon over time, and time, this could be measured in seconds or minutes, whatever. We'll probably be a little bit more specific when we do them. But in this case, they're asking us what are the variables for this particular graph. So for this one of the variables is going to be time, like I talked about, and that's represented on the x-axis. Okay. And over a period of time, I'm blowing air into this balloon. So the other variable is volume of air. And that's represented on the y-axis. Okay. So that's just kind of what you have to look at. What's on the x-axis? What's on the y-axis? You know, my hot air into the balloon, and it's going to blow it up. Okay. We're also going to blow it up until it pops, okay? So the second question that goes with this graph is describe how the variables are related at various points on the graph. So the first one we look at is always going to be right here at the beginning. So there's no air in the balloon, but the clock hasn't really started yet. So everything's at 0, 0, all right? So as I blow air into the balloon, over however long I can do that, the volume in the balloon is going to increase, okay? But at this point, if you're looking at this, time is continuing without stopping, but the volume of the air stopped. So I think at that point, I'm taking a breath. So all these other points that are kind of flat, the time is still continuing, but the volume is not increasing at those points. So it must be I'm taking a breath at that point to get more air into the balloon. You'll notice that after I take a breath, that the volume starts to increase again, okay? It's the next point that we kind of look at is right here. Remember, at a certain point, I'm going to blow it up until it pops. So it looks like at that point, I blew so much air into it that the balloon pops. Okay, so that's interpreting a graph. What's going on? What are the things that are causing it to happen, whatever it is, and you're able to make a kind of distinction there, okay? Okay, the next graph is just, you're going to be asked to try this, but I'm going to do it with you, okay? And remember too, guys, when we're doing these notes, just make sure that if you're getting kind of, you're not able to stay with me because I do try to go quickly, just hit pause, get your notes caught up, and then go ahead and do it, all right? So in these questions, once again, we're going to identify the variables. What's the x-axis representing? What's the y-axis representing? And then what's happening at certain points, okay? So if you look at this, the x-axis is, once again, it's time. Okay. You look at the y-axis, and it's length. Okay. And if you look at this, it's a board. So I'm going to assume that I'm cutting a board with a saw, perhaps. I'm cutting a board. So as time goes on, I must be cutting a board. And as time goes on, what happens to that board? Well, the board is going to get shorter with time. Okay. Okay. This next one is my June cell phone cost. So once again, identify the variables. The x-axis is, again, it's time. If we're being kind of thinking, it's minutes, so we could say minutes instead of time, and it says that right there. The y-axis is cost, so how much it's costing me to use my phone. Okay. So if you look at this, the first point you're looking at, I have to pay for my whatever my plan is. I have to pay a certain amount at that point. I haven't made any phone calls yet, or haven't had any time on my phone calls yet, but I have to pay for it. So that one is the cost initially. And then I'm going to make a certain number of phone calls, minutes of phone calls. I don't know how many that is, but at this point, what happens is that my cost goes up. So my plan must be I get a certain number of minutes, and then after that, my cost increase. So that point is cost goes up when minimum or maximum minutes are reached. So my plan is saying I get this much for this many minutes, and then after that, the cost is going to go up. Okay. All right. This next one, we're going to have a chart over here. This is called a T chart or a T table. Okay, because it's in the form of a T. All right. And what we're looking at is there's this band, and they've made some videos they put on their website, and they're kind of tracking the downloads of this video, and they're kind of seeing how many are done each day. Okay, so as I look at this, I'm looking at the change in downloads per day. So if you look at it, the first day was 346, but then I went up to 1,011. So I almost increased by 700 between day 1 and day 2. If you look at from day 2 to day 3, I increased a little bit more than 2,400. And then if you look between day 4 and day 5, I increased almost 7,000. Okay, so I'm looking at how they, what change there was, and it's going up each time, but it's not going up the same amount. And the key is that they're always increasing. So I've got these 4 graphs. Which one represents that table? Well, this graph represents a negative a negative slope or a decrease in numbers. So that one's not going to work. Okay. The C one looks like it's increasing, which is what mine was doing, but it looks like it kind of is going to flatten out, and mine wasn't flattening out. It was really getting bigger each day. Okay. This one, A, shows that it probably was the same change each day, which means it's like 100 each day. But this one didn't increase by 100 each day. It increased by 700, then 2,400, then 7,000. So this one represents that table much better. It's increasing, but then it just kind of takes off, and that's kind of what our table did. So B would be the selection for that. For the next one, you got this model rocket, so let's sketch a graph, and we'll call this the x-axis, this is the y-axis. Let's label each one. This rocket's going to take off quickly, and then it's going to slow to a stop as the fuel burns out, and then it begins to fall quickly until a chute opens, after which it falls slowly to the ground. So what sketch would represent the height of the rocket during its flight? So let's call the x-axis, once again, time. How much time was it in the air? Here, we'll call the y-axis height. And we don't have any numbers here. We're just going to sketch something, okay? Okay, I'm assuming that the rocket's going to start at 0, 0. Okay, right before it hits liftoff, it's going to be on the ground and no time has elapsed. I'm assuming that through the story that when we do hit it, it's going to take off pretty quick, okay? At a certain point, it's going to start to slow down as the fuel burns, so it's going to not rise as quickly. At some point, it's going to stop gaining height, and then the chute opens. Draw a little chute, and it's going to drop slowly to the ground, okay? Or to the x-axis. Okay, so that, it's just a sketch. We don't have numbers or anything, but that's kind of shows what the rocket did during its after it got launched. Okay. All right, so make sure you get your classwork done. If you got any questions, please ask. And let's make sure that we're always identifying variables in our graphs.